This is how-to videos, work and energy, example 6C, conservation of momentum. We have Taekwon riding on a roller coaster. It's got a couple of hills, and the first hill is 25 meters high. So initial height is going to be 25 meters. And that is where the initial velocity is, which is going to be 4 meters per second. And then he goes over the second hill, which is 15 meters per second. So this is H final, and then V final is also going to be here. H final is going to be 15 meters. And the question is, what is his final velocity? So how fast was he going? Once again, we don't really care about mass, so mass equals blah. So we're going to use a conservation of mechanical energy. So potential energy initial plus kinetic energy initial equals potential energy final plus kinetic energy final. If we look and we say, oh, unfortunately, we can't cancel anything out yet, so let's go ahead and expand this. mgh initial plus 1/2 m, that's a half, v initial squared equals mgh final plus 1/2 mv final squared. The thing we can cancel out, once again, is the mass. So mass is all cancel. It makes it a little bit easier, and seeing as we weren't given the mass, it definitely makes it easier to solve. So we are in fact looking for the final velocity here, so let's go ahead and move everything to the other side. So we have gh initial plus 1/2 v initial squared minus gh final, and that is equal to 1/2 v final squared. Okay, so I'm going to multiply both sides by the 2. So 2, and then I'm going to plug in my values here. G times the initial height is 25 meters plus 1/2 the initial velocity, which was 4 meters per second, so that whole thing squared, minus G times my final height, which was 15 meters, close parenthesis, equals VF squared. Tap, 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 I get square roots of this whole business. It's 2 square root, all that stuff in the parenthesis is 106, and then I have that as equal to my final velocity. I finish solving and I get 14.56 meters per second. So that's lovely. However, I could have done this a little bit differently. Instead of saying that this is 25 and that this is 15, I could have said this here is 0 meters, and I know the difference between them up to here is going to be 10 meters. So final height is 0 meters, and this is 10 meters. Now you say, well, what's the point in doing that? I recognize how there is the difference between them. I'm using the lowest point that I'm discussing or calculating as 0, because that should help cancel things out. Because now I can go back and I say, oh, look, the final height is 0. That was this guy here. Okay, so rewriting everything up here in blue, I have GH initial plus 1/2 V initial squared equals, and this was 0, plus 1/2 V final squared. So I got rid of one of the terms, and it's just a little bit easier to work with now. 2 times the whole thing, G, and then I'm back using my initial height as 10 meters times 10 plus 1/2, and my initial velocity is still the same. It's still the 4, but that's going to be squared, and then close parenthesis, and that is equal to v final squared. Okay, and then I go ahead and take the square root of both sides, and I end up with the exact same answer as before, 14.56 meters per second, or rounding off to a more reasonable number of significant digits, I can say 15 meters per second. Anyhow, it's the exact same thing as that was down here. Just little shortcuts.